All right. So vocabulary and definitions. Now that we've kind of ran through and did the problem, let's just kind of make sure we are clear on some of the words. And then some of these words are going to be new. They're leading you into either statistics or calculus. So that's the new parts. Okay. So when we are given a data point XY, what we're looking at is the deviation of a data point. Okay. The deviation of a data point, that's our Y minus our Y average, our prime, our average. Okay. And that's us finding that direct distance. Okay. Your deviation is saying, how is it separating? How is it changing? Right. The residual of the data, which is what we just calculated, that's when we did our Y minus our Y hat. Right. This is the vertical direction. Like, what are we calculating here is our vertical distance from the point on the line to the actual point that you're giving your data point. That's your residual. Okay. Your deviation is a little bit different. It's talking about your average and finding the difference from there. All right. The next thing we want to make sure is error. When it's asking you for error, it's the reverse of your residual. Okay. That's going to be key to note. So coming down here, vocabulary that we should be comfortable with. Your regression is the line of best fit. That's our least squares regression line. Okay. So if I was given a set of choices and it says, which one of these best model it, I'm going to look for the one with the smallest least squares regression value. Does that make sense? I'm going to look for the smallest R squared. All right. Now, residual is your actual minus your predicted. Your error is your predicted minus your actual. Okay. So residual is what? Actual minus predicted. So only Annabeth got that. What is our residual? Y'all feel like I can do a little bit of that. What's our residual? There we go. What is our error? Predicted minus error. That's it. I can't talk. Predicted minus actual. Okay. All right. RAP and EPA. How I think about them. RAP and EPA. That's where I've gone in my brain since statistics. RAP, EPA. And just go from there. Or 8 backwards, in case that helps someone else. Just saying. Okay. All right. Oh my God. All right. So here, if we were given the set and we needed to find all of these things that we just did, could you do it? All by yourself, try not to talk, go through it. Do you feel confident in completing this and finding these values? Yes. Okay. Now, we're going to do it also within our all in stat edit. So notice here, this time we did stat edit and we did things by hand. Do y'all remember in Algebra 2 where we did it all in stat edit? Like it actually, our L3 calculated everything we needed to find our distance and all that good stuff. We're going to go over that and try that here in stat edit. Are we ready to try it? All right, here we go. So we have a new set of data. And again, I like to just go ahead and clear Sylvia out. So second plus 712. Sylvia is cleared. She's ready. So I'm going to go to stat, edit. I'm going to put in my L1, which is going to be my X values, my L2, which are going to be my Y values. So we have 1, 2, 3, 4, 5. Then I'm going to put in my L2s, 2, 1 and 2/10, 3 and 6/10, 3 and 2/10, and 4. All right. We just want to make sure that we are testing a linear or make sure that these are linear. We're going to check the plot. So I go to Y equals. I'm going to go to plot 1, turn it on. And then it is very important that you go to zoom 9 or you won't see the points. Mm-hmm. All right. So now I'm going to decide, I have what I see. I'm going to say, okay, out of my options, linear probably is a doable fit. So I'm going to go to stat, calc, and we're going to find our linear. Is it? I wrote the wrong one. Okay. All right. So I'm going to store this. I was making sure we were all there. Are we all there? Are we good? Oh, I did it. All right. I feel like I skipped something.
Yeah, we don't have any instructions about how to do it. I mean, how to do that. The linear thing on ours, it just says go straight to second staff. I mean, second white. Well, you have to have the, our instructions don't say that we make the, I don't understand the regression.
Store reg equation. It doesn't have this.
Yeah, ours doesn't have anything about making a regression. Our notes, it just says you put in your point and then you go straight to second white.
All right, so after you calculate it and have put everything in and you sort it, when you go to graph, your graph will look something like this. So then from there, we're now going to find our residual plot. Your residual plot is going to be different than your scatter plot. So we're going to actually be doing it in a second stat plot. So when we're looking here, it says we're going to, it doesn't say this, but I don't know why it doesn't. We're going to go to second y equals, and we're going to go to plot 2. And we're going to go to plot 2. We want to turn on plot 2. And this is where you want your X list to be L1. So we're going to keep that as L1. And you want your Y list to be your residual. To get it to say residual, you're going to press second stat, and it's not 9, but it's 7. So, and this should be 7. And it's going to put that in place. So now once all this is in place and turned on, you're going to regraph. So you're going to go to zoom, go to 9, zoom stat, and that's going to regraph so that you can see your residual plot. So your residual plot are now the red dots. And like we learned in Algebra 2, you want it to be in like a equal scatter around the x-axis to say whether it's a good model or not. And so here is your residual plot. To be able to get the calculated values of your residual plot that you have without actually doing it, we're going to go back to stat, go to edit, and we're going to go over to L3. You want to go up to L3. Once you're at L3, you're going to then put in your residual plot. So to make this equal to your residual plot, that's where you're going to press second, stat, 7. I have no clue why it says 9. And then enter. And it's going to fill in those values. Again, this is not 9, it is 7. Okay. What's the benefit of this is that now you can actually square, you can find the calculated values, you can find the total. So if I come over to L4, I can go up to L4 and I can say, I want to square L3. To square L3, as you can see right here, your L's are at the top of your numerical digits, 1, 2, 3, 4, 5, 6. So I can hit second, L3, and we're going to square it. And it'll even find the square values, okay? If you want to find the sums and totals from here, you actually have to leave this window. So I'm going to leave this window. And I'm going to go to second stat. And you see where it says ops. You're going to go over to math. And you can find the sum. So if I wanted to find the sum of my R, not my R squares, but of my R, that's my list 3. So I would hit second L3. And there are my sums. And it's 0, which is a good thing. And then I'm going to find the sum. So stat, over to math. And I want to find the sum of my squares. I'm again going to go second, and this was L4. Press enter, and that is going to be the value of it. So 1.84 is a pretty small area, which is why it's my least square residual. My least squares model. But that's how that would work and how that turns out. Following through that step. So with that, going through, ignore the background music. Or just sing along with it. All right. So what is our residual plot? It is a type of scatter plot. It's showing how the residuals on the vertical axis. On your residuals are around your vertical axis, so your positive x-axis, and it helps us decide whether this is a good model or not. So when you are what you're looking for is random fit. So a random linear model. So if it's random, equally placed up above and below on, that's a random linear model. Notice here, this is giving me a U shape. So this would be an example of a non-linear model. This is giving me an inverted U shape. Again, an example of a non-linear model, which means that a linear regression is not going to be the best fit for whatever I'm modeling. And that's kind of how that all comes together. Okay, we will pick up here on how to interpret a residual plot tomorrow.